All right, for our next lesson, we are going to work with rational exponents, and all that means is rational is like a rational number. So that means we're talking about fractions. So as we look into the exponent, we're going to see some fractions here. So the first thing I want to show you is how this works on your calculator. So if we're going to work with 216, and we want to take that to the, see how we do this, 1 divided by 3 power. So we can set it up just this way. We find out it's 6. Well, hopefully that rings a bell, because you remember that the cube root of 216 is 6. So that's what we're going to explore just in a second here, is how we're talking about the third root. So we're going to get rid of that square root symbol. Before we do that, we want to review a couple things. We do have like bases over here. So if we have that, what we're going to do is add those exponents. So that means we're going to do 1/2 plus 1/2, and we're going to have 7 to that power. So it's 7 to the first power, which is just 7. So although we're going to show you some new things, don't forget about the things that you already know about exponents, because that will make your life a little bit easier. So here's what we're trying to explore in that top frame, is just dealing with this. So the square root, right, if there's no number in the index, we call this the index, and that means it's the second. And that means we have a root down here. So what we're saying so far is 36 is to the first power, and it's the second root. So if we want the cube root, just like we did with 216, that's the 1/3 power. So the 1/4 power is the fourth root, and that's how we deal with those. Now remember, your rules are, we want to make sure we have the same base before we can do anything with it. So 125, that's not really the same as 5, but 125, that's not 5 squared, but does happen to be 5 to the third power. So this is 5 to the 1/4. This is 5 to the third power, but it still has this 1/4 on it. What do I do with a power to a power? I multiply them. So this is 5 to the 1/4 times 5 to the 3/4. Now that I have the same base, I can go ahead and multiply, which means for exponents, we're going to add those. So this is 5 to the 4/4, which is 5 to the first, which is just 5. I can see how we don't need all these previous steps in here. But again, this is applying something you have done before and putting it together in just a little bit different light, so we can work with those. All right, now the upside is we want to make sure we can change them back and forth. So up above we had 5 to the 3/4. We said this is the power over the root, in case you didn't jot that down up above. So 5 should be to the third power. To see it in radical form, I should put a 4 in the index. So being able to transfer these back and forth is going to be helpful as we move through the chapter, because that's the concept. And sometimes it's easier to see it as a square root sign, and sometimes it's easier to see it as the fractional exponent, the rational exponent. Okay, so we just got to make sure we can do these. Other important thing is you can solve them in either way. Typically, we want to take the root first if we can, because that makes the number smaller to work with instead of larger. But if for some reason it's a really small number, it might be better to make it doing the third power first. Right, so these are just convert them. So here we go. We have x to the 3/7. So I have x to the third power. The 7 must be the root, so it hangs out as the index. B gets a little bit more confusing because we threw a decimal in and threw a negative in. So let's ignore the negative for just a minute and just deal with 3.5 for the power. Why did I do that? Because when we see it as a mixed number, we start to understand that I can say 2 times 3 plus 1. So this is actually the 7/2. So this becomes the square root of y to the 7th power. I am going to put a 2 in here, so I realize the index is that. But what about the fact that it was negative? What do I do with that? Well, what happens because of that is we end up putting the whole thing in the denominator. So my final answer becomes 1 over the square root of y to the 7th. So just being able to transfer them back and forth, back and forth. So w to the negative 5/8. Well, hopefully the first thing we notice is it's going to be 1 over whatever we do to this. The next thing we know is going to be w to the 5th power. So the last number that we have left over becomes the index, because that was in the denominator. Power over the root. Power over the root. 5th power, 8th root. All right, next one we have w to the 0.2. Again, any decimals we're going to change out. So that's 2/10, which is 1/5. So w will be to the 1st power, but the 5th root. Just being able to transfer these back and forth is the goal to get started. What about the expressions? So this time we want to go from this radical form. Remember, radical means we have a square root. We want to change it into that fraction. So we have the 4th root of x to the 3rd. So x will be to the 3rd power, but it's also to the 4th root. So these are a little bit nicer. There's not as much thinking going on here. And again, the order doesn't matter. It is y, it's to the 4th power, and then the root is 5. So it takes care of that last one. Now, of course, once we know how to transform them, then I can ask you to simply put them together. I say simply, but we're just reviewing some exponent rules. So quick review, x to the 5th over x to the 3rd. This means we do 5 minus 3, so it's x squared, and that would be in the numerator, so we don't need that at all. Because if I'm dividing, I have to subtract. Why did I bring that up? Because we're about to divide, but these don't look the same at all. So let's first change them out. So it becomes x to the 3/4 over x to the 2/8. Well, 2/8 can be reduced, so let's do that first. 3/4, and that becomes 1/4. Over here I did 5 minus 3, so now I'm thinking about what's 3/4 minus 1/4. Give you common denominators here, because I know that's a little bit new. I have to do a lot of changing around, so it becomes 2/4. 2/4 becomes 1/2. That means your final answer is x to the 1/2 power. How else might you see your answer? X to the 1st power with a square root. And so either one, it doesn't say which way to write your answer. So to make sure you see both, as this is the major point of the lesson and how we're transitioning these back and forth. All right, we're going to write each one in simplest form. So we have 3, and this is the square root, so it's the 1/2 power. We want to multiply it by 3. The 4th root is the 1/4. I have the same base, and I'm multiplying, so I'm going to add those together. So what's 1/2 plus 1/4? Well, 1/2 becomes 2/4, right? 50 cents plus a quarter, so we're looking at 3/4. So it's 3 to the 3/4. All right, product and quotient in simplest form. So that would work, or 3 to the 3rd power and the 4th root. Either one of those would work. All right, in our next one, it looks like we're going to divide. So I'm thinking right now that I have to subtract something. So let's figure out what I have to subtract. So I have x to the 3, there's no index. Remember, that means 2 over x to the 2/3. So here's my major goal. My major goal right now is what is 3/2 minus 2/3. Common denominator is going to become 6. So that means I need to multiply by 3. So I have 9/6 minus, this is going to become 6. So I got to multiply by 2. 4/6. So 9 minus 4 is 5/6. How else could you see your answer? X to the 5th power, and we squeeze a 6 here in the index. Okay. All right, last one. This looks very similar to A. So I'm going to give that a try. 7 to the 1/2. Remember, no index means an index of 2, 7 to the 1/3. All right, so this time we have to take 1/2 and add 1/3. Again, we're going to use 6 as a common denominator, just like we did before. So times 3 times 3 times 2 times 2. Why are we doing that? Because I'm trying to make those denominators 6. 3/6 plus 2/6 is 5/6. So final answer, 7 to the 5/6. How else might you see that answer? 7 to the 5th power, taking the 6th root. Either one of those will work. All right, we're going to write this in simplest forms. So we have trying to make it a little more complicated as we progress here today. All right, so we have negative 8x. That seems odd, but we do have to distribute. Hopefully that yellow is showing up just enough for you. So we want 2/3 on the 8, 2/3 on the x. Let's spread that out a little bit more. And then the next thing I have is a clump of xy that is already to the 1/2 power, and we have to take that to the 2/3 power. All right, so -1, eventually we're going to square it because the top here. So we're going to keep that, eventually it's going to become positive. So I'm going to make that a plus. Now the cube root of 8 is 2, squared is 4. So numerically we're done with it. But now I have this x to the 2/3. I have an x to the 1/2, but also to the 2/3. So this is where it starts to get layered just a little bit. So let's go ahead and put both of these together to get started. So this would be x, this would be 2/6. Okay, I know we can reduce that to 1/3, right? So since the y would be the same thing, I'm going to go ahead and reduce it to 1/3. The next thing I'm going to do is take my 2/6 and make it a 1/3, because I now have the same bases in the middle that we need to put together. So it's 2/3 plus 1/3. Since I'm multiplying, I'm going to add my exponents. So 2/3 and 1/3 is 1. So it's 4x, we can say to the first power, y to the 1/3. So you can see how quickly we're going to start to layer these together and make sure we can handle all the little details, power to a power. So your exponent rules are going to be super duper important here. Let's zoom in a little bit here. So we went 16 to the 3/4. Well, the 4th root of 16 gets me down to 2, and cubing it makes it 8. And so I'm going to make sure I take 16 to the 3/4. That's going to become 8. And it's actually going to become 1/8. The next thing we'll have is y to the -8 to the -3/4 becomes, which way do you guys work with this? Top times the top. So we go 24/4. All right, so it's going to reduce down to 6. And we had a negative times a negative, so it's positive. So it's y to the 6th. So these are the things I have to put together now. And since it's y to the 6th that's in the numerator, I'll have y to the 6th over top of 8 for my final answer. So it gets a little complicated at the end here with some negative exponents, but just take your time. And just like I did here, I tried to illustrate by doing one item at a time. Right? We first dealt with 16 to the -3/4, got that answer, and in the end, I'm going to put these two answers together, doing this multiplication left in between them to get my final answer with the location of each item, since we had some negative exponents going on.